Okay guys, so good day sa inyo. Again, I'm Sir B and I'm here to discuss about our new topic which is all about friction. Okay, so simulan natin. So let's define first what is friction. Okay, under 5.1 or the friction defined, so sabay-sabay natin basahin. So friction may be defined as the contact resistance exerted by one body upon a second body when the second body moves or tends to move past the first body. From this definition, it should be observed that friction is a retarding force which always acts opposite to the motion or the tendency to move. As we shall see, friction exists primarily because of the roughness of the contact surfaces. If the contact surfaces are perfectly smooth, as assumed in some earlier problems, friction can be neglected. Okay, so again, friction is defined as the contact resistance. So take note of this. Ito yung ilang sa keyword na kailangan mo lang tandaan tungkol dito sa ating topic na friction. Again, this is the contact resistance between two bodies. And tandaan nyo that kung yung second object mo or yung first object is hindi mo naman gagalawin or there's no force that will act on that body na magkokosaan niya para mag-move, guys, walang friction na mangyayari. Again, from the other videos na napanood ko, yung friction daw is isang tamad na force. So, ano siya? Naka-base siya doon sa mga forces na naka-apply doon before ka magkaroon ng friction. So, kung yung body mo is nakapatong lang sa surface, so walang friction na mangyayari. Ano? So from this definition, it should be observed again. So please take note of this again. This is a retarding force, and this acts opposite to the motion or the tendency to move. So opposite the motion. So ibig sabihin, if your body will go to the right, then your frictional force or your friction will act to the left and vice versa. Again, opposite to the motion. And friction exists primarily because of the roughness of the contact surface. So nakadepende siya sa surface na pinagpapatungan niya or yung second object na nag-a-act do sa surface ng iyong first body na ina-analyze. Okay? So bawat materials meron kang iba't ibang coefficient of friction. So later on malalaman nyo kung ano ba yung tinatawag na coefficient of friction. So yan, may iba't ibang values. So though sa ating mga previous problem, so from the equilibrium topic, so madalas nyo sigurong naririnig itong term na perfectly smooth. So kaya niya sinasabing perfectly smooth ang iyong surface is to neglect the frictional force. Okay? At the same time, wala naman binibigyan na unit doon or value ng coefficient of friction, so there's no need to consider the frictional force. So guys, itong topic na friction na ito is just a application ng topic na equilibrium of force system. So yun lang din yun. Ang nangyari lang dito guys is kailangan mo lang i-apply yung frictional force, and from the definition, it is always opposite to the motion. So para ka lang talaga ng equilibrium topic na nagdadagdagan ka lang ng isa pang force, which is the frictional force. And kailangan mo lang din siyang i-relate do sa mga equations na ma-discuss dito sa topic na to. Okay? So let's proceed with the next topic. So this is the theory of friction. So under 5.2, so ito lang po siya. So basahin natin itong kanyang statement dito. The following experiment is useful in discussing the principles of friction as applied to dry unlubricated surface. So unlubricated, ito is assumed na rough yung kanyang surface. So let a block of weight W. So ito daw, yung block mong to is a weight of W which rests on a rough horizontal surface. So nakapatong siya dito sa rough horizontal surface na yan. Assume a horizontal force P to be applied to the block. So on this point, meron kang to the right na force which has a value of P. So meron kang horizontal force dyan. And as shown in figure 5-1, so ito nga yun. So when P is 0, so the frictional resistance is 0. Okay? So again, gaya nga ng sabi ko kanina, yung frictional force which is designated by the symbol F, but sometimes ito is ang kanya is denoted by F sub F. Okay? So on your other books, so ganyan yung kanyang designation ng frictional force na to. But anyway, ito lang din yung gamitin natin siguro, F sub F. So that is the frictional force which is acting to the right. Again, opposite to the motion of the body. So meron ka ditong horizontal force P. Sabi dyan, when the value of P is 0, therefore, the value of the frictional resistance is equal to 0. And when P is given increasing values, then the frictional resistance also increases. So, ito pala is directly proportional dun sa applied force P. Okay? Yung value ng frictional force mo. So, yan is makikita doon sa graph under figure 5-2. Guys, so ito, ayun nga, gaya ng sabi ko, the friction is directly proportional to the applied force P. From where it is producing 45 degrees, so dahil nga directly proportional siya, any changes do sa applied force P mo is magkakaroon ka rin ng corresponding changes do sa iyong friction. So, uniformly increasing yan. And then, at the maximum available force, maximum available friction, motion, impending, so ito yung maximum value ng iyong frictional force kung saan once na na-exceed ka dito sa value na to, magkakaroon ka na ng movement o gagalaw na yung iyong block na yan. So under this, dito sa portion na to, dito sa part na to, ito is papatak na doon sa kinetic friction from where the motion will occur. Okay, so imagine nyo na lang guys, di ba? For example, ikaw, nakatungtong ka sa ground and then yan, yung contact mo between those sa ground ay meron kang corresponding na value ng mu or d. Salamat, Shopee. Or meron kang coefficient of friction. Okay, so di ba ikaw is nasa rest pa lang? Walang nangyayari sa'yo kahit may weight ka, since wala ka namang ina-applied na force para gumalaw ka, walang frictional resistance na nangyayari. Although, yung frictional force mo, meron yang maximum value. So, siya ay equal sa mu or yung coefficient of friction multiplied by the normal force. Okay, so mamaya i-discuss natin kung para saan ba yung normal force na yan. Meron kasi yung maximum value before ka magkaroon ng motion. Okay? So, for example, maglilin ka do sa wall or itutulak mo yung wall. Okay? So, ayan. So, di ba, lagyan mo ng konting puwersa. So, syempre, yung frictional force mo, magkakaroon din ng corresponding changes. And then, once na na-applied mo yung maximum na force which will impede motion, ang mangyayari dyan, unti-unti ka nang gagalaw eh. Ano? So, dito sa explanation do sa book, so, kapag nasa static portion ka, o do sa static friction, from where there is no motion, mahirap kasi magsimula eh, gumalaw, once na nakaling ka sa wall. But once na na-impend mo yung motion or nag-start ka ng gumalaw, unti-unti, bababa yung value niya. Okay? So, yan po yung sinasabi dito sa table natin. So, once na gumalaw ka, magkakaroon ka ng drastic change or decrease do sa iyong applied force P. Na-apply. Once na gumalaw ka eh, ano? So, if mag-experiment kayo, try nyo. So, maunawaan nyo yung sinasabi ko. Ano? Nasa na tayo dito? So, the graph indicates that up to the impending motion, the frictional resistance F is numerically equal to the applied force P. But after motion occurs, the frictional resistance decreases rapidly. Okay, so ito yan. To a kinetic value which remains fairly constant. So, yung frictional resistance mo will drop or will decrease rapidly. Okay? So, from such experimental results, it is observed that as long as the block remains at rest, the frictional resistance must equal the resultant force tending to cause the motion. This is true up to the instant at which the frictional resistance can no longer balance the resultant of applied forces. When this condition exists, motion occurs. Once motion takes place, the frictional resistance drops to a value below that acting when motion starts. So ayan lang din yung sinasabi ko kanina. Once na nag-start ka ng motion, yung frictional resistance mo, or same lang din ng value ng force P, kahit counting force na lang i-apply mo once na nag-start ka na kasi gumalaw, mas madali na siya. Okay, so the relation between the frictional resistance F and the coefficient of friction F, so ito, yung coefficient of friction niya is designated by small letter F na naka-italic yata to. And the normal pressure N at the surface of contact is expressed by the following equation. F is equals to F or the coefficient of friction multiplied by the normal force. But meron akong isang version ng formula or equation na to na sa tingin ko mas madali nyong masasaulo. Kasi ang topic na friction is ayan. So hindi naka-install yung drawing pad ko. So mano-mano natin siya inaano. Ayan. So nabasa dyan. So ito, fun daw yan. F-U-N, fun. Masaya daw yung topic na friction. Okay? So para mas madali nyo na lang din maunawaan o masaulo, so F sub F stands for the frictional resistance or the frictional force. So that is equals to the mu, or yung mu natin is the coefficient of friction. This coefficient of friction is pwedeng maging mu sub k for the kinetic and mu sub s for the static. So ito yung condition natin kanina. So again, yung static when there is no motion, and then kinetic siya kapag meron ka ng motion na nangyayari. And then N, that is the normal force. So this is based on the weight of the block itself and the y component or the vertical component of the applied force P, which will cause the motion to the body. Okay, so note that this equation determines only the maximum resistance which can exist when motion is not impending. The friction may have any value from 0 up to the value of F, depending on the resultant force tending to cause motion. Okay, so let's proceed with the next topic. Okay, so this time we will now discuss the 5.3 or the angle of friction. Okay, so from the figure 5-1, so ito yung kanina siya, is redrawn in figure 5-4. So ito na siya ngayon, okay? So to show that F and N are really components of the total reaction R exerted by the plane surface against the block. So itong N and F, or in the frictional resistance and the normal force, is just the Y and the X component of the resultant R. So in short, yung R mo is just equals lang saan? So sinasabi niyan that is equals lang sa F, or pwedeng F sub F squared plus N squared. Okay? So component lang daw yan ng iyong resultant R, yung N and the F na yan. So the size of the angle between R and N, so ito po siya. So take note that yung angle phi mo, or the angle of friction, will always come with respect to sa iyong normal force. So dyan lagi magmumula yung iyong angle phi, or the angle of friction. So the size of the angle between R and N depends on the value of the frictional resistance F. If F is 0, therefore this angle will be equals to 0. As F increases, so does the angle. So the particular value of this angle when maximum frictional resistance is acting is defined as the angle of friction, or yung angle na phi na ito. Okay? So it acts at its maximum value of theta only when motion is impending. So from this figure, it is apparent that the angle of friction may be defined by the following relation. So ayan, so parang yung ano lang, topic ng mga resultant, di ba? Or tangent theta. No, this is not theta. This is tangent phi. So pa-correct na lang po ito. So this is phi, okay? Angle phi. And also for this one, this is not theta, this is also equals to phi. So that tangent phi is equals to F over N, or opposite over adjacent. And since yung iyong frictional force, di ba kanina yung F sub F, is equals do sa iyong mu times N. Okay? So when you're going to rewrite that, we see that yung iyong F is equals do sa tangent theta. Kasi if you're going to rewrite this, di ba yung mu natin is equals lang saan? So F sub F equals lang siya sa F sub F over N. Okay, so dito kasi sa book ito yung gamit niya. But ito yung tinuro ko sa inyo, yung fun ng friction. So, di ba ito is equals lang din dito. Yung F nga dito guys, again, that is F sub F over N. So in short, if you're going to equate this two equation na to and this one, ano ang mangyayari dyan? Di ba yung tangent phi is equals lang sa coefficient of friction. So guys, take note of this equation or the relationship between the angle of friction and yung iyong mu, or the coefficient of friction. Okay, so tangent phi is equals to mu. Okay, so this is a very important equation. Okay, so in other words, the tangent of the angle of friction is yun. Ito pala, sinabi lang din dito. It's the angle of friction. Hence, determining the angle of friction affords a means of obtaining the coefficient of friction. Okay, so this time, we will now discuss the 5.4 or the laws of friction. Ito yung mga kailangan nating tandaan kapag nagsosolve ng problems with respect to sa topic na friction. So guys, yung mga problems natin is mahati lang sa tatlo. Yung mga conventional friction problems, and then further problems in friction, ito yung mga complicated na konti. And then, so isa na yan, di ba? And then meron tayong topic for wedges. So parang yun lang din naman yun. Ito naman guys, again, ito sa application lang ng iyong naunang topic, yung equilibrium of force system. Yun lang din yun. Nadagdagan nga lang ng isang force. And then yung mga following equation, yung tinuro natin kanina. So isa ito. And then yung fun na equation. And then yung resultant. Okay? So yun lang yung nadagdag doon actually. So other than that, ito is lang din. Equilibrium of force system lang din yung approach dito. Okay, so ito lang yung mga kailangan tandaan for the laws of friction. So the summary of the principle discussed in the preceding articles may be called the laws of friction and may be stated as follows. So basahin natin. So for number 1, so if friction is neglected, the reactions are always normal to the surface in contact. Okay? So for number 2, friction always acts to oppose the motion. So ito nga yung kailangan pinaka-importante, oppose the motion of the free body or its tendency to move. It is tangent to the surface in contact. Okay? So tandaan, oppose the motion of the free body. So ito pala yung isa pa rin sa importante dito. So guys, di ba sabi ko sa inyo, dapat magaling kayo mag-imagine dito sa static of rigid bodies. So dito, dapat, unlike before na kahit mali yung assume natin, the negative sign will tell you if tama or mali yung sagot natin. But on this law, dito sa topic na friction, napaka-importante guys nung galaw ng system ng mga arrangement ng iyong body. Okay? So, napaka-importante ng paggalaw dito kasi doon nga naka-base kung saan papunta yung frictional force mo. And unlike doon sa unang topic na equilibrium of force system, unlike doon, dito kapag mali yung assume mo ng direction, maling sagot po yung mapapalabas natin. So, dito kailangan i-apply mo yung galing mo sa pag-imagine kung paano ba gagalaw yung mga object mo based on their connection, based on the applied force, paano siya gagalaw, kung saan yung frictional force. Okay, number 3, if static friction is acting, the value of the friction force may vary from 0 to a maximum available value, depending upon the resultant force tending to cause the motion. Okay? So the maximum available value of static friction, so the limiting friction when motion impends, is equals to F sub S or the mu sub S multiplied by N, where mu sub S is the coefficient of static friction and N is the normal pressure or the normal force. And for number 5, if kinetic friction is acting, so the friction force is constant at its limiting value. Actually, kinetic friction decreases somewhat at high velocities and increases at very low speed. So, makes sense naman, no? Di ba kapag mabilis na yung takbo mo, parang wala ka na kasing friction na nararamdaman. Mababa na yung value. Unlike kapag, kapag bumabagal yung velocity mo, ang nangyayari, nagkakaroon ka ng increase dun sa kinetic friction. So, ito lang yung sinasabi dyan. So, the kinetic friction is equals to F sub K times N or mu sub K, where mu sub K is the coefficient of kinetic friction. Ay, parang naulit. Anyway, so number 7, the angle between the total reaction and its normal component when limiting friction is acting is called the angle of friction. The tangent of this angle is the coefficient of friction. Okay, so further problems in friction. So under 5.5, in some of the problems, it will be simpler to use the frictional and normal components of a surface reaction. So dito papasok yung resultant. So again, yung resultant mo, that is just a component. Ang component niya is yung frictional resistance and yung normal force. So sometimes pwede mong gamitin yung component na lang. But in other cases, since marami ng unknown, ang ginagawa dyan, pinagsasama yung dalawa para maging isa na lang yung unknown mo or yung variable, which is the R or the resultant of that. In other, we should use the total surface reaction. So ito nga yun lang din yung sinabi ko kanina. A general rule is this: when the normal pressure can be computed directly in terms of known forces, use the frictional and normal components of the surface reaction. But for the other case, use the total surface reaction. Further, when only 3 forces act on a free body, usually apply the sign law, the triangle of forces. So dito papasok yung tinuro natin before, no? Yung different approach in solving a equilibrium of force system. So pwede kang gumawa ng force diagram kung saan maka-form ka ng triangle, and using sign law, mahanap yung mga unknowns. Okay? So see, dito nagbigay lang din ng tip. So when the normal pressure can be computed, so ito siya, directly in terms of the known forces, use the frictional and normal component. So kapag masosolve mo agad yung normal force, gamitin mo yung dalawang component. But if not, if marami masyadong unknown, then use the resultant. Okay? When more than 3 forces are involved, of which only 2 are unknown, it is suggested that force summation be taken with respect to the perpendicular axis, one of which coincides with one of the unknown forces. So dito rin papasok yung mga tinuro ko before. So kapag ikaw is nasa inclined surface, so kailangan mo mag-adjust ng axis, i-adjust mo yung x and y axis mo, mag-shift ka ng axis para ma-eliminate mo yung mga forces na pinapahanap. So finally, for non-concurrent system, always consider the possibility of eliminating 2 of the unknown forces by taking a moment summation about the intersection of their lines of action, or if this is not convenient, consider force summation that will involve one or at most two of the unknown forces. By applying this suggestion, it will usually be possible to determine each unknown quantity independently of the others. So, ayun nga lang din to. So, ito lang din yung sinabi ko kanina kung saan ito is application lang ng equilibrium of force system. So, yun lang din ang gagawin mo. So, if I were you, try to review the previous topic para at least mas fluent yung way ng pagsosolve natin dito. So, para mas makabisado nyo lang. So, actually guys, madali lang talaga to. Mangyayari nga lang, so if hindi mo kabisado yung mga naunang topic natin, so maapektuhan yung mga susunod na topic. So ito na nga yung isa sa topic na maaaring maapektuhan if hindi mo nakabisado yung pagkuha ng yung equilibrium of force system. Okay? So ilan na lang. So guys, itong 5.7, we will just skip this. And last two topics tayo. Itong rolling resistance, so skip na lang din natin to since walang practice problem sa libro. So we have two other topic which are wedges and the belt friction. Okay? So discuss ko na lang siya once na magsosolve na tayo ng mga problems para sa topic natin yun. Okay guys, so para mas maunawaan nyo yung topic na friction, magsosolve tayo ng mga problems dun sa susunod nating video.